Good morning, students. Welcome back to this data structure class. We resume from what we have left in the last class. That is, in the last class, we discussed about doubly linked list. The figure of a doubly linked list is given here. Every node is made up of three members. One is a member for the previous pointer for the previous node, the data value pointer for the next node. So every node will have two pointer members, one data member. In this picture, you see the node having 5, having a pointer field for the previous node, pointer field for the next node. The node having 10, he is having a pointer field for the previous node and a pointer for the next node. Like this 15 is having a pointer for the previous node 10, pointer for the next node 20. Now the next field of the last node is null. The previous of the first node is null. This is the figure of a doubly linked list that we have discussed in the last class, and in the last class we have discussed about creating a list, finding an element in the list, checking whether an element is full or empty. These things we have discussed in the last class. Especially we have defined, we have understood how to find for an element in the list, and that is going to be used in this class now. Now in this class we are going to discuss about inserting a value into the list and removing a value from the list, then displaying the contents of that list. Okay, now we go for those things now. So our next function is void. The class name is DLL. The name of the function is insert. What value to be inserted? Some item. This will be the value for this item will be from the main method, main function. Okay. Now I am going to insert a value. The value I am going to insert might be the less than any of the values available, or greater than any of the values here, or in between any of those values. That is, I am inserting the node having value 2, or inserting a node having 25, or inserting a node having 13. 13 means the value 13 should be inserted between this 10 and 15. 2 means it should be inserted before this 2, and 25 means it should be inserted after this 20. So all of these things should be taken into consideration when you try to insert a value. So wherever you are going to insert, first of all, you should need a empty dummy node. In that, the value to be inserted should be copied. Then there should be a correct pointer manipulation of the new node into the correct location. Okay, those things we are going to discuss now. Now, I need several pointer local variables. So they are pointing node type. You know, so node type, I will say star L, comma star previous node. So star P, comma star NN. NN means new node. NN means new node. Okay, these are the things that I want. Okay, now I need one more variable found to know whether the element has been founded or not, because such a variable is used in the find element function. So int found. int found. Okay. So as I said now, I need a dummy node first of all. So NN new node, NN is equal to new node type. New node type. Okay. Then in the data field of this node pointed by this NN, the value to be inserted, that is, this item should be copied. So NN reference info, NN reference info equal to item. NN reference info is equal to item. Okay, this is the understanding. Now, I forgot to mention some more points. That is, you may try to insert a node into a empty W linked list, or you may try to insert into a existing W linked list. So, how do you know whether it is an existing list? If it is an existing W linked list means, then the external pointer is not pointing null, rather it is pointing a first node of the existing W linked list. So our external pointer here is LD. So I'm checking what does this LD is pointing. If it is pointing null means, then you are going to insert into a empty W linked list. Otherwise you are going to insert into a existing W linked list. So you check what does this LD is pointing. So if LD uh, is not equal to null, is not equal to null, if LD is not equal to null, that is, you are trying to insert into a existing W linked list. Now you find for that value item. So you call the find item mechanism now. So find item, where do you want to find? In the list pointed by this LD. Okay, LD, comma. What to find? This item has to be found. And if it is available, which should point the node? The L should point the node. L should point the node. Which should point the previous node? P should point the previous node. And how to know whether the element has been found out or not? There should be this found function. If found is equal to 1, the element has been found. If found is equal to 0, the element has not been found. Okay. So if the element has been found, then there is nothing to insert because the element is already available. So we are trying to insert a value that is not there. So found should be equal to false. So if found is equal to 0, if found is equal to 0, if found is equal to 0. Now you check where to insert the new value, whether it should be inserted before any of the given nodes or in the middle or last of any of the given nodes. So for that you check the value, okay, to be inserted. Okay, now you do how to know whether the element is going to be the very first element. If it is going to be the very first element, our location would be pointing the very first node. Okay, the very first node is already pointed by LD. So if L is, sorry, if L is equal to LD, if L is equal to LD, if L is equal to LD, that is, if the element is going to be inserted into the very first node, then that is, for example, I'm going to insert the value 2 means, then my new node should be somewhere here. My new node reference next should be pointing this node. Then my new node reference back should be pointing null. And after inserting this one, my LD should be pointing this new node. That is what my understanding is. So that's what we are going to do it now. So so after inserting this one, the back field should be pointing null. So currently this backfield is pointing null. Well, how do you refer this backfield? Location reference next or LD reference next. Both are same here. So okay. So assign the value of location back to new node back. So new node reference back is equal to L reference back. New node reference back is equal to L reference back. Then new node reference next is equal to location, because location is currently pointing this node. Okay. New node reference next equal to location. Then uh, then there should be a connection from the current first node to the new node. How do you access this node? Location back. Location back should be pointing new node. So L reference back should be equal to new node. L reference back should be equal to new node. Now, after inserting this one, my new node has become the first node. First node should always be pointed by the external pointer LD. So, LD is equal to NN. LD is equal to new node. That's all. Now, the element is inserted as a first node. Element is inserted as a first node. Okay. Else supposing you are inserting the value 25. You are inserting a value 25. In that case, my location would be pointing null. My predlog would be pointing this one. My predlog would be pointing this one. Here, my predlog is P. Okay. So, So if my location is equal to null, if my location is equal to null, then my new node is going to be somewhere here. This node is pointed by P. This is P next. A connection should be from P next to the new node. So the value of new node should be given to P next. And before that, you should give the value of this P next to new node next, because after inserting this one here, the new node will become the last node. The next field of the last node should be pointing null. Currently, my P next is pointing null. The value of this P next is given to new node next. So P reference next is equal to new node reference next. That first you do that. Then you make this P next point new node. Okay. P reference next is equal to new node. Then so my P next is pointing the new node that I am going to put it here. What happens to new node back? A new node back should be pointing P. Pointing P. So new node reference back is equal to P. So new node next is pointing null. P next is pointing new node. New node back is pointing P. That's all. I think we have made all the connections. New node next is now, that is the new node is going to be here, it is going to be null. Then P next is equal to, connection from here is given here. Then connection should be from new node back to the P. So connection is given from new node back, is given the value of P. That's all. We have inserted it as a last node. Else what to do? That is, okay. Else I am going to insert somewhere in the, sorry, I'm going to insert it somewhere in the middle. That is, supposing I want to insert the value 13. It should be somewhere here. So what is the mechanism of doing that? My new node will be somewhere here. New node next should be pointing this 15. This 15 is already pointed by, this is pointed by L, this is pointed by P. So new node next should be pointing P next. Then L back should be pointing new node. New node back should be pointing this P. These are the various operations that we are going to do it, but we should do it very carefully, otherwise we may end up with garbage location pointing. Okay, else new node reference back is equal to location back. New node reference back is equal to, so this is location, supposing I'm inserting 12, then this is location is pointing this node, P is pointing this one, so this is location back. New node back is given the value of location back, so new node back will be pointing the node having 10. Okay, then then a connection is from this node to new node. This is pointed by P. So P next is equal to new node. So P reference next is equal to NN. P reference next is equal to NN. Then connection be given from this back to the new node. So location back is equal to, that is L reference back is equal to new node. Then from new node reference next is equal to L. So we have successfully inserted into a existing list. Else, what is that case? Else, that is, if you try to insert into a empty list, that is, what is this else? Else is meant for this one. If location is equal to sorry, if LD is equal to not equal to null, this is the so. So what happens when LD is equal to null? That is, you are trying to insert into a. So that's why you are putting this one. Else, then my LD will be pointing the new node. That's all. Else, LD is equal to new node. Then the front and back field of new node should be pointing null, because that is the only node. So new node reference next is equal to null. Then new node reference back is equal to null. Back is equal to null. That's all. We have done most of the almost all the insertion part that we have taken into consideration. Okay. Next, one more thing is some more things are remaining. That is removing a value from the WA linked list. Those things we will see in the coming class. Okay.